Welcome to a place where the questions no one dares to ask are exactly where the most chilling truths begin. One day, time itself might stop. All motion will freeze. No more tomorrows. No more change. And the most terrifying part, even endings, could end. Time could die. And the universe would turn to stone in a moment that lasts forever. We've always believed that death is the final chapter. But modern science reveals something even darker. Even the end might not exist at all. If that moment comes, there will be no after to hold on to. No next time to try again. Not even one more breath to fix what was lost. Before Einstein shook the world, people thought time was a steady beat, a ticking cosmic clock. But he showed us. Time plays by no rhythm. It stretches, it twists, and yes, it might stop. Have you ever felt gravity pulling you down? That wasn't just a force. That was time itself, dragging its feet beneath your body. If you knew time was ending, what would you choose to do? What would you say in your final moment? Time doesn't just pass quietly. It feels. It reacts. It flows with everything around it. Like musicians playing together in a vibrant rhythm. But harmony can break. Sometimes, time is like a drummer who gets too caught up in the beat, plays too fast, too wild, and suddenly burns out. When time reaches its limits, scientists call those moments singularities, points where time might begin or come to an absolute end. The most famous singularity is the Big Bang. Around 13.7 billion years ago, the moment that launched the universe and gave birth to time as we know it. But what if the universe stops expanding and begins to collapse? That might trigger the reverse of the Big Bang, a big crunch, where time freezes, as if it had never existed. Still, time doesn't end everywhere. Inside black holes, according to relativity, time truly ends. But outside, in the universe, it keeps flowing, moving, ticking. You've heard black holes can swallow anything, right? The truth is far worse. If you were to fall into one, you wouldn't just be torn apart. You'd also... What do you think waits beyond the edge of time? If you could step into that boundary, would you dare? Eventually, you'd reach a place called a singularity, buried deep at the heart of a black hole, where your timeline ends completely. There would be no rebirth, no scattering of your remains into something new. It's not just death, it's an existential collapse, the unraveling of your very being, as if you never were. Physicists have long struggled with this haunting reality, that relativity predicts such a bleak finality, with no second chances, no redemption. Even now, the brightest minds still can't fully comprehend what a singularity really means. And that's why they chase the ultimate dream in physics, the unified theory. A theory that could blend the grandeur of Einstein with the quantum precision of the subatomic world. A dream called quantum gravity. Much of this pursuit is driven by a hope. A desperate hope. That maybe, just maybe, singularities could be explained away. Erased. Rewritten. But such a hope comes with its own questions. What if time never ends? Would that be comforting? Or terrifying? Long before Einstein, philosophers were already lost in this thought. Immanuel Kant called it an antinomy, a paradox with strong arguments on both sides. Time might end, but it might also never stop. If you were trapped in a timeline that could never die, would that be a gift or a curse? Antinomy, a philosophical paradox, is when both sides of an argument seem right, yet they directly contradict each other. a mental loop with no clear escape. Immanuel Kant, the great philosopher, recognized that time itself falls into this paradox. It makes sense to believe time is infinite, unending, an eternal river. But it also makes sense to believe time could be limited, that it might reach an edge. Aristotle struggled with the same thought. He believed time couldn't have a true beginning or a final end, because every single moment marks both the close of something in null way and the start of something else. Every event is caused by something that came before and leads to something after. So how could time possibly stop? What could halt the final event from triggering another? Even more puzzling, how do you define the end of time, when end itself relies on the existence of time? Richard Swinburne, philosopher at Oxford, argues that the end of time is logically impossible. But if time is endless, then doesn't that mean the universe must exist forever? Never fading, never collapsing, never ceasing. Does that comfort you? Or does it leave you more hollow than ever before? We once thought we were closing in on the truth, when the Big Bang Theory gained acceptance, when black holes became more than just theory. It felt as though we were finally grasping the answers to how the universe began and how it might end. From the Big Crunch, a collapse into itself, to the Big Rip, where all is torn apart by runaway expansion, to the Big Freeze, a cold, eternal silence, or even the Big Break, where physics itself unravels. But the closer we got to singularities, the more questions we uncovered. Do singularities even exist at all? Lawrence Sklar, a renowned philosopher of physics at the University of Michigan, once pointed out that the very theories giving rise to these strange entities also cast doubt on their reality. Take the Big Bang, for example. Relativity tells us that every particle in the known universe, all the galaxies, stars, planets, dust, were once compressed into a single mathematical point, a point with no size. Likewise, inside a black hole, every atom of an unfortunate object or astronaut is squeezed into a point so tiny, it defies understanding. In both cases, the math leads us to one result, dividing by zero volume, and that gives rise to infinity. If your universe began with zero and ends in the infinite, where exactly are you living? In between those two extremes? Not all singularities are the same. There are singularities where the infinite comes into play, though not necessarily infinite in density. Modern physicists aren't as afraid of infinity as Aristotle or Kant once were, but they still treat it as a warning sign that perhaps a theory is reaching the edge of its usefulness. Take a simple example: the standard ray optics theory, taught in classrooms everywhere. It explains eyeglasses and funhouse mirrors beautifully. But its math claims that light from a distant source is focused by a lens into a single, perfect point, a spot of infinite intensity. In reality, light doesn't focus to a perfect dot. Instead, it forms a bullseye pattern, and its brightness, while high, is always finite. That's because light doesn't behave like a simple ray. It moves as a wave, gentle, and far more complex. Likewise, most physicists believe that cosmic singularities, terrifying as they may be, don't actually involve infinite density, just extremely high density. They suspect that near these edges, Einstein's relativity breaks down, that it can't fully describe gravity, or matter's true behavior under extreme conditions. Physicist James B. Hartley from the University of California once said that to truly understand these limits, we may need a completely new way of thinking about space and time. So what lies beyond the edge of our theories? A deeper truth? Or the ultimate boundary of human understanding? At the University of California, Santa Barbara, many physicists agree on one thing. Singularities aren't where everything ends. They're where our theories begin to fall apart. To understand what truly happens in these extreme conditions, we need something beyond relativity, something deeper, a quantum theory of gravity. Though still under development, physicists believe this future theory will include a key insight from quantum mechanics. Matter, like light, has a wave-like nature, and this wave-like behavior might gently blur the sharpness of singularities. Instead of a point with zero size, a singularity might become a tiny, fluctuating bundle of energy, a soft quantum blur, eliminating the error of dividing by zero. If this turns out to be true, then perhaps time might not end after all. Still, the debate continues. Some physicists do believe that time does come to an end. But if that's the case, it leads to an even greater challenge. Because every law of physics we know operates within time. They describe how things move, how things change, how one moment leads to the next. If time ends, those laws would become meaningless. We would need a new kind of law, one that doesn't rely on time. No more talk of motion or change. Only timeless principles, rooted in geometry, in spatial structures, in something constant and unchanging. Can you imagine a universe where there is no before or after, no beginning, no end, only being? Some physicists don't just search for answers in equations, they search in geometry. Take Brett McInnes from the National University of Singapore. He proposed a bold idea based on string theory, a leading contender for a quantum theory of gravity. He suggested that the early universe may have had the shape of a torus, like a cosmic donut. Mathematical theorems about tori state that such a shape must be perfectly smooth and symmetrical. But near a singularity, like the Big Crunch or inside a black hole, that symmetry could collapse entirely. At the edges of reality, those mathematical rules might simply break down. The universe could become wildly irregular. And this is the core difference between geometric laws and the traditional dynamic laws of physics. Geometric laws lack time symmetry. In this view, the end wouldn't just be the beginning played backward. It would be something new, something irreversible. Meanwhile, other researchers in quantum gravity argue that time stretches infinitely, with no true beginning or end. They see the Big Bang not as a starting point, but as a transition, one moment in the ongoing life of the cosmos. According to them, the universe may have already begun collapsing in a big crunch long ago, only to rebound again when the density reached its threshold. So what do you choose to believe? A universe with a beginning and an end, a perfectly framed story, or an endless universe, where every end is merely another door to pass through? We nuked space and nearly destroyed ourselves. Like, comment, and subscribe to uncover what else they're not telling us. When matter reaches a certain critical density, something extraordinary might occur. A phenomenon known as the Big Bounce. Instead of collapsing into oblivion, the universe might spring back, rebound from its own final breath. Traces of that prehistoric era may still linger somewhere in the cosmos today. Similarly, some suggest that the singular bundle inside a black hole isn't just a dead point, but could behave like a tiny star, boiling, bubbling, alive. If you were to fall into a black hole, yes, the end would be painful, but your timeline might not end completely. Your particles would be drawn into the core, leaving behind a subtle signature that might, just might, be detectable by future observers, in the faint light radiating from the black hole. If time continues endlessly, we wouldn't need a new class of timeless physical laws. But even this view brings its own challenges. The universe tends toward greater disorder over time. So if it has existed forever, why isn't it already lost in total chaos? And that light carrying your imprint, how could it ever escape the immense pull of the black hole? The battle with the paradoxes of time isn't just a physicist's dilemma. For centuries, philosophers too have stood before these very questions. And even today, we are still wandering through that same maze. For centuries, humanity has stood before a single haunting question. Does time ever end? John Archibald Wheeler, a legendary figure in quantum gravity, once made a profound remark. Einstein's equation says, "This is the end." But physics says, "There is no end." Faced with this paradox, some have given up, believing that science may never offer a final answer, that the boundaries of time may also be the boundaries of reason and of human observation. Yet others remain hopeful, trusting that with enough creativity and time, physics might shine light into the unknown. Gary Horowitz, physicist at UC Santa Barbara, affirms, "This is not beyond the reach of physics. Quantum gravity should be capable of providing a definite solution." As physicists and philosophers wrestle with the end of time, many draw deep parallels to the end of life. Just as life emerges from inanimate molecules, self-organizing into something complex and conscious, time, too, might emerge from something deeper, something timeless, waiting to be discovered. Because without time, what is the universe? No before, no after, no order, no duration, no when. Perhaps time is simply the way the universe tells its story. Perhaps time is the way the universe tells its own story. But if there's no more time to tell it, would we still know what it means to be alive? And you, if there were no past or future, what would you choose to hold on to, so you never forget who you are? Structure isn't something imposed from the outside. It emerges from within. And like everything that's ever been built, it can crumble from within. As that structure breaks down, time begins to fade. From this perspective, the end of time isn't some grand mystery. It's no more puzzling than the breakdown of any complex system. It doesn't arrive with thunder. It slips quietly into twilight. The first sign of its departure may be the loss of direction, that familiar arrow we trust to guide us from past to future. But since the mid-19th century, physicists have known a startling truth. That arrow is not an inherent property of time. Time itself can flow in both directions. What we experience is simply matter drifting from order into chaos, a phenomenon familiar to anyone who lives with pets or young children. That early order may have come from the geometric principles McInnes proposed. And if that trend continues, the universe will eventually reach a perfect, silent balance. A state with no change, no energy, no movement. A moment physics calls heat death. When the universe reaches a state where it can no longer become more disordered, change comes to a halt. Individual particles may still shift and rearrange, but the universe as a whole stops evolving. Any remaining clocks, if they still exist, would begin oscillating in both directions. The boundary between future and past starts to blur. Some physicists have speculated that the arrow of time could reverse, that the universe might somehow begin to tidy itself back up. But for mortal beings like us, whose very existence depends on time flowing forward, such a reversal would be just as devastating as heat death itself. Recent research suggests that beyond the arrow of time, another fundamental aspect may vanish: the very concept of duration. In our current understanding, time is measured in seconds, days, and years. But without these units, we might still witness events unfolding in sequence, yet never be able to grasp how long they last. A moment could stretch into forever, or vanish in an instant. This unsettling idea was proposed by Oxford physicist Roger Penrose in his book Cycles of Time. an extraordinary new vision of the universe. Throughout his life's work, Penrose has chased a single question. If time can end, could it also begin again? And if time one day forgets to count, would we still know what it means to exist? If you could step outside time, no clocks, no sequence, no change, what would you hold on to? In his lifelong quest to understand the nature of time, Roger Penrose, alongside Stephen Hawking in the 1960s, uncovered something extraordinary. They showed that singularities, those regions of infinite density, aren't rare glitches in the fabric of space, but fundamental to how the universe works. Penrose went further, suggesting that when matter falls into a black hole, it ceases to exist in any meaningful way, and that time itself might not even be required in the most fundamental laws of physics. In his latest work, Penrose turns his gaze toward the very first moment, the early universe, a wild and chaotic storm of particles, like a box of Legos shattered across the floor, waiting for someone, or something, to build a story from the pieces. Among the chaos were quarks, electrons, and other elemental bits of matter. And then, order began to emerge. Step by step, layer by layer. Atoms formed, molecules followed, then stars, then galaxies. The first great leap came about 10 microseconds after the Big Bang, or perhaps the Big Bounce. It was then that protons and neutrons were born, each made of 3 quarks, each no larger than a millionth of a billionth of a meter. Before that moment, no structure existed, just a restless ocean of potential, waiting to take shape. But if time itself, at least as we know it, was born from this rise of order, then when order collapses, will time vanish with it? And if you could stand at that first threshold, watching chaos give way to cosmos, would you call it a beginning or a miracle? Before structure, before meaning, before time itself, there was no thing made of parts, no object built from smaller components, and because of that, there was no way to keep time. Every clock you've ever known, pendulums, quartz crystals, atomic oscillations, they all rely on a stable reference, something that repeats, something that stays the same long enough to measure change. But in the early universe, none of that existed. Clumps of particles may have come together for a moment, but they had no fixed size, no consistency, not even quarks or electrons. Those supposed building blocks of matter had any observable size. When examined up close, they dissolve into mathematical points. The only trait that resembles size is their Compton wavelength, a strange quantum property inversely tied to mass. But even that fragile reference was missing, because at that stage, less than 10 picoseconds after the Big Bang, mass didn't exist yet. The very process that gives particles mass hadn't happened. Without mass, without structure, without repetition, there is no ticking, no beat, no way to say what comes before or after. Without something to mark a regular interval, Penrose explains, you can't keep time at all. Whether an attosecond or a femtosecond passes, it makes no difference to the particles in the primordial soup. So, if nothing could tick, did time even exist at all? If the universe itself didn't know how to measure change, how did it know when to begin? That bleak scenario doesn't just characterize the distant past of the universe. It might also be a chilling glimpse into its farthest future. One day, when the final star flickers out, the universe will be left in utter darkness, with nothing but a desolate sea of black holes and stray, drifting particles. And eventually, even those black holes will dissolve into nothingness, leaving behind only particles, massless, weightless travelers like photons. And when only this cold, weightless light remains, building any kind of clock becomes impossible. Even in alternative endings, like the catastrophic Big Crunch, clocks would stand no chance. You might think that duration could still exist in concept, even if we can't measure it. But here, the deepest question arises. Can something truly exist if it can't be measured, not even in theory? If time is defined by what a clock measures, and if no clocks can ever be built again, then is there really still such a thing as time? Heinrich Zinner-Nagel, a philosopher of physics at the University of Granada in Spain, who has long studied the possibility of time's disappearance from the universe, firmly asserts, if there are no clocks, then there is no time. And what's terrifying is that this end, a universe without time, without change, without even the notion of before and after, is not science fiction, but a real, serious prediction drawn from our most advanced physical theories. So, if the future truly becomes a place where nothing ever changes, nothing ever moves, and nothing can ever be measured, would we even still exist within it? However, that bleak vision isn't without its cracks. Not all particles in the distant future will be weightless wanderers. Some electrons will likely survive, and if so, wouldn't it still be possible to construct a clock from them? Penrose acknowledges this, but he also proposes a bold idea that somehow these electrons might lose their mass in the deep future. Yet even he admits, it's a speculative leap, uncertain and far from proven. This is one of the most controversial aspects of his theory. Another paradox emerges. If the early universe had no concept of scale, how could it have expanded, thinned out, and cooled down at all? Still, if Penrose's theory holds, it leads to a breathtaking conclusion. Despite their apparent contrast, one a seething, dense chaos, the other a cold and hollow stillness, both the early universe and the distant future share a profound similarity. Both lack clocks and any meaningful measure of scale. Penrose himself notes, the Big Bang and the far future are eerily alike. And then, he puts forth an idea that could rewrite everything we think we know about time. That the end might actually be a beginning. That the universe doesn't die. It turns the page to a new cosmic cycle. That when time reaches its end, it folds in on itself, rewinds, and ignites a brand new Big Bang, an eternal loop, where every ending is simply the start of something else. Just when we thought singularities marked the death of time, they might, paradoxically, be its very cradle. What was once feared as the executioner of time now whispers of its rebirth. Even if time loses its sense of duration, even when femtoseconds and attoseconds blur into a meaningless haze, time may not be entirely extinguished. Its heartbeat may grow faint, but it still pulses in the background of reality, guiding cause and effect. Unlike space, where objects can simply coexist without any script or direction, time demands order. You press a key, and a letter appears on screen. That's not coincidence. That's time, weaving its invisible thread. But even this sequence, this precious order, may one day fade. Under extreme conditions, time could lose its role as conductor and become just another dimension, no different than space. This haunting idea isn't new. In the 1980s, Stephen Hawking and James Hartle dared to imagine it. They proposed that the Big Bang wasn't the birth of time, but the moment time and space split from a single essence, fueled by the radical implications of string theory, which suggest our universe may be just a membrane, floating in a higher dimensional cosmos. They speculated that in certain conditions, time could fold, fade, or morph into something utterly unrecognizable. Under specific conditions, time might fold in on itself, vanish, or transform into something entirely unfamiliar. If time were just another dimension of space, would your memories still make sense? What do you think? What would happen if tomorrow no longer had a before or after? Time could merge with space. Imagine our universe as a leaf drifting in the wind, with us trapped on it like caterpillars. Normally we can move freely within our four-dimensional prison, But if the leaf gets buffeted too violently, we become immobilized. To make progress along this cosmic membrane, we would need to move faster than the speed of light, which is impossible. As a result, all processes come to a halt, because every process requires movement, and movement becomes unattainable. From an external perspective, our life's timelines, once formed by a sequence of moments, wouldn't actually end, but instead curve, becoming spatial lines. In this scenario, the membrane remains four-dimensional, but all four dimensions become spatial dimensions. Matter is forced to accelerate ever closer to the speed of light, until its trajectory exceeds the speed of light itself, effectively erasing time altogether. Crucially, the individuals undergoing this transformation might not even notice it, because all clocks would gradually slow down, then stop, and we would never realize. And if time can truly vanish, then perhaps the most precious thing isn't the past or the future, but this very moment, the one you're living right now. Because maybe all we ever have is one single chance to exist, to feel, and to understand that the universe isn't only measured in light years, but in the beating hearts of those who dare to wonder. We nuked space and nearly destroyed ourselves. Like, comment, and subscribe to uncover what else they're not telling us.